Nghe chừng có vẻ các bé ngủ muốn dậy muộn nhỉ. Hương ơi,
Dạ.
gọi thằng Mai Thành dậy đi, sao nó ngủ quên.
Vâng.
Trong lúc chờ đợi các bạn xem video rồi nhá.
Chia sẻ màn hình như thế.
Các bạn xem là có nghe được tiếng video nhé. Nghe thấy không?
Có nghe thấy rồi không?
And G, what we call the gravitational acceleration, which is approximately the same everywhere on Earth, but it is very close in Boston, 9.80 meters per second per second. And you will say, well, that's real meters per second per second. What that means is that if you have an object and you drop it from a very large altitude, very high, a few hundred meters high, and I dropped it to zero speed, after 1 second it will have a speed of 9.8 meters per second. But after another second it will add that 9.8 meters per second, so it's twice that. And after 3 seconds it's 3 seconds. So now you understand why it is meters per second per second. So that's the meaning of G. There is something weird about this equation. Something that must go against your intuition. And you shouldn't feel bad because it also goes against my intuition. So we have the pendulum. And suppose I bring the pendulum all the way out here. We call that the amplitude of the pendulum. And we let it swing back and forth. There's a certain reason. But now we bring it out only this far. It doesn't have to travel very much at all. Doesn't that make a difference in periods? The equation says no, it doesn't. Because if it did make a difference, there would be in that equation the amplitude which is not. And I'm going to demonstrate that it is quite remarkable that indeed that period is independent of amplitude if you don't go to extreme values. There's something else in here which is even more notable. And that is whether the bulb, we call this bulb, whether it is 1 kilogram or 500 kilograms, you would think Well, that must be different. It must make a difference. But the equation says, sorry. No? Yeah, I'm going to demonstrate it. We have here, by the way, if you ever want to test this pendulum, this equation for yourself, put in L equals 1 meter and use this number, you will get a period of 2.0 seconds. Very easy. You at home, you make 1 meter, you put an apple at the bottom, and you swing it. There, the 1 meter has to be accurate. You see that it will be 2.0. Our pendulum that we have here is really the mother of all pendulums. Look at it. 15.5 kilograms, and the length of this pendulum is 5.21 meters. However, you must understand that it is very difficult to measure that very high accuracy. And so there is an uncertainty in the measurement of the length. We have to be honest about it because we are physicists after all. And the uncertainty we estimate is about 5 centimeters. So we could be off by 5 centimeters. That means that if 1%, 5 centimeters is 1% out of 521. But since L only shows up as the square root, it means the uncertainty in the time that we predict is only 0.5%. And if you don't see the reason why the 1% is 0.5%, that's okay, then just forget that. Take the word. So now, I can make a prediction. So I predict using this equation. That's all I do. I put in 5.21, I put in 9.80, I multiply by 2 pi, and I make the prediction that the period of that pendulum is 4.58 plus or minus 0.02 seconds. Why the plus or minus 0.02? Well, that is the 0.5% uncertainty due to the square root of L. And you can immediately see that 2 is about 0.5%. So my prediction can be no better than that. Now comes the problem. I have to measure the period to convince you that it is independent of amplitude and to convince you that it is independent of mass. So the biggest problem now is what will do it itself, which is my reaction time. How accurately am I able to make that measurement? That has nothing to do with our lack of knowledge of the exact length. Now, the last time that I gave this lecture with the pendulum is 12 years ago. I was 63. And at that time, I told the class my reaction time is 1/10 of a second. And it was. Now I'm 75. And so my reaction time is no longer over. What is it? Well, I do not know, but I have a feeling that if you want to be kind to me for a change, let us assume that my reaction